All right. So different electrical materials and where they can be used. Um, Kind of a short subject here. This is going a lot quicker than I thought, so we're going to be finishing up in probably about a half hour or so, just to give you an idea. So the first thing is EMT, also known as thin wall, also known as conduit. EMT stands for electrical metallic tubing. This stuff is bendable, and usually we just get it and we can pull the wires through it. It doesn't come with wires inside of it. I do want you to look at some of the fasteners that are present on here. These fasteners, such as this one right here, these are compression fittings. The compression fittings are only supposed to be used outside. What I'm going to circle in blue here, the ones with these screw fittings to tighten everything up, those are not to be used outside. Those are indoors only, all right? But the other ones are through. So depending on the size of the conduit and the pipes, determines how many wires and what size wires that we can pull through there. Quite frankly, we don't really notice too many problems with this. It's going to be really difficult to pull too many wires through this stuff. You're going to end up damaging the wires. So once it comes through, we see them damaged. Those are usually the things that we end up calling out. But it can be done. You can't pull too many through it, and then the pipes themselves are going to be hot. For those that use thermal imagers inside the panels, I think it's a great idea. See if which wires are hot. They could tell you if we're either overloading or too much bundling, or if we have loose connections. Just a nice simple thing we could do. Doesn't have to be foolproof 100%. EMT. So EMT could be used interior and exterior. Exterior has to be with watertight fittings. They're the compression ones. It is acceptable as a ground. But this is a big deal. So we don't have to have a ground wire inside of them. Now there is a push for this to have ground wires installed with conduit. And the reasoning behind this is, and I'm sure we've all seen it, is if that conduit comes loose, I just broke my ground for everything downstream of that, or everything on the work side. All right. So if this is my line side on this side, and then this is my load side, all right, and on the load side, I had a wire come loose and energize my conduit. If my conduit is disconnected, I don't have a pathway to get back to my panel that gets me back to my bond screw, that gets me on my neutral, and then allows that free flow electricity and trip the breaker. I got nothing. All I'm going to do is energize that conduit, and everything else that's attached to that conduit is going to be energized as well. All right. So the conduit is more than just protecting the wire and just the convenience of pulling wires through it. That's my ground path. All right. So making sure that those are connected, I can't stress that enough. Without it, if I do have a phase decay fault on the load side, there's no way for me to trip the breaker. Everything's going to be energized. And if somebody touches that and they have another ground path, whether they're barefoot on the concrete or water or touching plumbing pipes, the electricity will flow through them. All right. Bends need to be made smooth, no kinks. Secure 3 feet from the box, 10-foot intervals, Chicago 7. I don't really get into that. I just don't want to see these things loose. I'll go ahead and wiggle them when I come through it. Not acceptable where flexible connection is needed, such as to a motor. Okay, so in other words, if we have to be able to move something, then we have to have something that's flexible for that connection, is what he's saying. Not acceptable to connect to lay-in fluorescent lights, because we don't know, and what we're talking about is fluorescent lights in a drop ceiling. We don't know where those are going to land, and so they need to be moved a little bit. So we usually end up putting 6-foot whips on those so we can have access to it. If we go straight to it and we need to take that down, we're not going to be able to move that light fixture to get in there and fix or replace it. So we need to have that flexible conduit there. Coupling, connectors, lock nuts, everything should be tight. Everything should be secured. Again, goes back to losing that ground that we had on there. It's okay to be buried in concrete or earth, provided proper fittings are used. and the pipe is protected against corrosion. All right. So this one ended up getting twisted and pulled apart, even though they're still touching. So I still may have my ground path coming back in there. It's still not good enough for me. All right. If those things are loose and they could come apart, that's definitely something we should call out. This one's completely apart. We can see that we have the red wire and the white wire in there. So we have our energized conductor. We have our neutral coming back. But because my conduit is disconnected, if I get a phase decay fault anywhere downstream of this, it just gets energized and I don't have a pathway to come back. All right. BX. All right. BX or Armor Cable. They have the wires already built into them. So this comes from the manufacturer like this. All right. Those little red heads that you see on there, and let's see if I can, just because I'm having fun drawing on here right now. Those little red head there, they go on the tips of these things. They're designed to protect the wires from being cut from the actual cabling device themselves, all right? The extra wire that's in there, that isn't really a separate ground wire. We kind of tie everything together to give us our grounding system, but there's also not going to be an extra ground wire in there as well. So the Armor Cable, these are in short whips, 5 feet. We should be able to see that bare metal piece, and I'm talking about this piece way up there. All right. We should be able to see that folded over and folded back so that we know that everything's kind of connected and we have one continuity to everything coming across. Let's see some of the rules. Connectors are straight or 90 degrees, and those are those fasteners that we put on there. The connectors are not concealed, so we can't bury any junction boxes with these. We can fish these wires behind walls. We could do that actually in Chicago now. So we don't have to pull off all the drywall to run new electrical stuff there. We can actually fish the Armor Cable. But what we can't do is hide those connectors, all right? Sheathing is the ground. No ground wires in the cable. The metal thin strip is not a ground wire, but we want that bended back and visible. Paper wrap around the conductors. That's flame and moisture retardant. That's just to keep them somewhat dry. Anti-short is that red-headed bushing that I talked about so it doesn't get damaged by the conduit itself. All right. So we can't let it be subject to physical damage. In other words, somebody can't drive over it. It can't be exposed in a garage or someplace where people can step on it or hang on it or whatever. You can fish it in there. If it's run on the underside of the joist, it needs to be secured to each floor joist. If it's going against a wall, 4.5 feet, 12 inches from a junction box. That 12 inches is also the same thing for non-metallic cable. We'll get to that in a little bit. Whatever the thickness is determines how fast I can bend it, but quite frankly, if you bend these things too much, then they're just going to start breaking and coming apart. So, BX. What else we got here? It can be unsupported if it's laying loose on top stuff or running behind a wall. Length's 2 feet or less at the termination points where flexibility is needed. This is where we were talking about those can lights in drop ceilings or fluorescent lights, anything where I need to be able to remove something and move it around. That's what it is. And really it's 6 feet is our magic number that I want to be aware of. All right. MC cable is kind of the same thing as Armor Cable when it comes with it. These, again, open and concealed, direct burial when protected, branch circular signal, similar to the BX or Armor Cable. Secured every 6 feet. Bending radius is 7 times. Wires are built into it. They do have a plastic wrap on it. Sheathing is not the ground on these. So I don't know if you caught it or not, but there was a separate ground wire in there. And that would need to be attached to whatever boxes that we have. All right. The green ground wire present and must be used. All right. Greenfield. these are basically flexible conduit. All right, liquid tight, seal tight. Even though those have a rubber coating on it outside, it's flexible conduit that comes in there. Now, certain jurisdictions like Chicago, and I was actually, thinking the wrong way on this one for quite a long time, and I do believe it says so in this drawing here, that these can be gone in unlimited lengths, but Greenfield cannot, all right? Quite frankly, if you ever try to pull wires through this stuff, you're never going to get more than 20 feet anyway. But it still falls under the same rules, about 5 feet when you're going to be doing it. But you can run it and fish it under the walls. Not really the most common thing that people are going to be using just because of the size of it, all right? So depending on how you're using it is whether or not you have to run a separate ground wire through this. But for the most part, the Greenfield can be used as your grounding conductor, all right? So not to be used, we're subject to industry within a foot from the box, every 4 feet. Fishing is okay, and it's unsupported when you fish it behind stuff. 6 feet connections. Minimum size is 1/2 inch. This is the unlimited length. Like I said, in Chicago, I don't think that's accurate. Longer than 6 feet, we do need a ground wire installed. Under 6 feet, no ground wire. And most of the time when we're dealing with GFIs, when we're dealing with Greenfield, we're going to try and keep those under 6 feet. Any length or any circuit over 20 amps also needs a ground wire. They do have 90-degree angle connectors. Those cannot be concealed. What else? Not permitted underground or embedded in concrete. And this is the seal tight version of the liquid tight that comes in here. All right. And seal tight is a trade name where it comes to it. Typically, most of our air conditioning circuits are going to be put in this way. Now realize that the seal tight also comes without that metal conduit. All right. And so what I tend to do is squeeze it. If I can pinch it, then there is no ground wires coming in there. There is no protection of my wires to it. All right. So I definitely need a ground wire coming into it, and that's not acceptable for our outdoor situations. All right. It can be buried if it's marked and listed for this, not to be used or subject to industry. 1 foot from the box, 4 feet every linear run. Does not need to be secured when flexibility is needed in lengths up to 3 feet. Okay. And this is, this just has to do with the size of the wires, how many amperage it goes on there, if it's okay for a ground or not on ground. And again, it has to do with the amperage and the size of the wires. You know what? You can never go wrong with throwing another ground wire in there anyway. But we want to be as accurate as possible. So knowing that this chart here, 25 amps or more, over 6 feet, it's not okay as a ground. 15 or 20 amps up to 6 feet, you can use it as a ground. So anything over 25 amps, we should have a ground wire going in there. And this again goes towards our feeds for our air conditioning units. And this is what we're looking at here. So here our seal tight actually came loose. I've run into connections for this seal tight or liquid tight where the connections themselves are plastic. And I'm talking about, this nut right there where that thing's plastic. In which case, if it is, then I don't have, even if it is connected, I don't have my, I can't use it as a ground at all, because the plastic will break the ground and go into the air conditioning unit. So I have 2 energized conductors in here, and I do have 1 ground conductor in there. There is not a neutral conductor going through this, but again, if it feeds my air conditioning units, I don't have to have that. All right. Non-metallic cable. I also want you to know the term NM cable. NM stands for non-metallic. NMC stands for non-metallic cable. All right. Also known as Romex. Romex is a trade name. It's the manufacturer's name, but a lot of people do refer to that. I like us to refer to things as being non-metallic cable or NMC. This one would be a 14-2 with ground. All right. So non-metallic cables, they started color coding them. Older systems, I want to say in the 70s, maybe, oh, I'm sorry, in the early 2000s is when they started color coding these things. And so white would be 14, yellow would be 12, and orange would be 10 when we're dealing with non-metallic cables. And then when they say the first number is going to be the size, the second number will be the number of conductors, and then the third thing is whether or not it has a ground with it or not. So this would be a 14, which is the size, 2 conductors, hot and neutral, and ground. I can actually use this to connect an air conditioning system. All right, it's okay to use the white wire as an energized conductor. We should relabel it as black, so putting tape on it is good, but it can be done. Okay for use on 1 or 2 family dwellings in any height. Suspended ceilings. You know, it's not so much in the city of Chicago and the suburbs around here. We kind of do everything in conduit, and we don't really use non-metallic cable. You can run it underground too. They have UV protection and stuff outside like that, and those are all color coded as well. 12 inches, 4.5 feet, no limit on length. It can be fished. Doesn't have to be supported when you fish it. 6 feet, basically same rules as Greenfield. Type NM is not okay for direct burial. We do have to protect it from physical injury. So basically anything that's below 7 feet that's exposed needs to be in pipe, all right? Or behind drywall. It just can't be out in the open. It's not intended to be used to connect garbage disposals. So those wires under the sinks, because we're going to be going in there, we could bump things on it, we could damage it, and that's why we're not supposed to use it for that. Cannot run perpendicular across basement joist. Needs to be on a linear running board, number 8 or larger, so they have to have something, especially up in attics, and you're going to see this all the time. When you go up in an attic, they don't want you to be able to walk on these wires and squish them, because once we start squishing and damaging that, we're going to be damaging the insulation, and we can start creating a parallel arc when it happens. So parallel on joist is okay. What else? Protected by conduit when passing through floors. Not always happening. So here we can see we come out of our junction box. Within 12 inches of that box, we need to be secured. As long as we don't leave a way for, the wires that are loose. So when they're going through the stud, then they need to be protected with nailing plates. But if they're out in the open like this, then they don't have to. All right. So looking at this chart on here, I know there's something here that says about 1.25 inches. This is all Chicago or all of Illinois. It's Chicago. We use a lot of non-metallic cable in central Illinois. That I know. It's pretty much the collar counties in Chicago is where this comes into play. Thanks, Mark, for bringing that up. But as far as non-metallic cable, just about everything that you're going to use out there or outside the city of Chicago is pretty much going to be NMC. In fact, just to be really clear, other than New York, Chicago, and Los Angeles, everywhere else in the United States of America, and I'm talking about the city itself plus the surrounding burbs and the locale around the city, everywhere else in the United States, they all use non-metallic cable for residential buildings, all right? Everything for commercial buildings has to be in conduit, but residential buildings, non-metallic cable is just fine. So what you're going to have down there is just fine. But they still need to be secured. They still need to be supported, whether it's on every floor joist, up against the floor joist, if it runs through a hole. If it's less than 1.25 inches, I have to have nailing plates on it. We still have to protect the wires. We can't just leave them all floppy and loosey for what it's worth, Here they're showing bundling. And if you notice where we go through the studs, first of all, we got those nailing plates that are up there. So when the drywall guys go there and start putting screws on everything, we don't want them to drive screws into these wires. Now it looks like our nailing plate is missing on a couple of the 12 gauge wires and 14 gauge wires. And I'm talking about this area, like right in here. We definitely want to call that out and get something connected to it. I think same thing on this one. Right in here should also have a nailing plate coming through it. Now the bundling talks about the amount of cables that are allowed to go through that opening that's on there. Now I get it. The wires on the left-hand side are cable and data. I'm all over that. But even though we still want to have those wires protected. However, the yellow wires going up there and the white wires, those are not. All right, those are non-metallic electric. The bundling of the wires, as we're seeing, kind of loose in there, going down the studs. Yeah, that's not so much the problem. It's where they go through the holes is where we're going to be concerned. Because that ends up squeezing everything, and then you get a lot of ampacity that comes out of there. All right. This is something that I've never really seen at all, or actually I have. I've seen it a couple times, but it's really rare. I think a lot of people refer to this as like Smurf tube just because it's blue where it comes into it. But it's a plastic, flexible conduit. It's obviously because it's plastic, we can't use it as a ground. We need to have a ground wire running through it as well. But there's going to be some areas where I guess it's okay, but we really don't use that up here in the Chicago area. Knob and tube. There's a lot of insurance companies now that are not, they don't want to insure homes that have knob and tube wiring in it. And it's kind of a big deal when we come through it. But identifying it, to me, it's a problem. I let my clients know. I have them check with their insurance companies if we run into it. It's not a mandated defect that we tell people because the wires are tin-cladded copper that we normally see. But this stuff is old. This is turn of the century 1900 old. And it's all out in the open. It was not, some of it you'll find in conduit as well, when they merge in newer systems to it. But it's all old. It was all subject to damage and overheating. And we just do things with the plastic insulation so much better. So I would continue on asking my client to recommending that they check with their insurance company and make sure it's there. But nonetheless, I'd like you to know some of the rules, all right, and where they get the names and everything else from, all right? So up here on the left-hand side up there, that's a knob, all right? So the distance on that knob between the floor joist there and then the knob where the wire is, that's actually 1 inch, all right? So when we talk about lifting it up, running off a parallel or on the floor joist or on top of stuff, that's supposed to have a 1 inch gap, all right? So the reason why they make those knobs 1 inch is to maintain that 1 inch gap. Right? So when I see stuff like this coming in here, where it's actually resting on the floor joist, even though the knob is holding it 1 inch up top there, I'm not maintaining that 1 inch gap on it as well. So parallel runs, so we're talking about, this wire here and this wire there. Those parallel runs need to be 3 inches apart. They need to be 3 inches apart. Anytime wires cross over each other, and I'm not necessarily seeing where too much they cross over each other. I guess you can make that argument there. Those need to be 1 inch apart as well. So anytime they go perpendicular, I have to have a 1 inch gap on here. Parallel, 3 inches minimum. And these are all test questions you're probably going to see if you're still taking the state exam. So I want you to memorize those numbers. 3 inches across, 1 inch here, 1 inch to the structure. It needs to stay away.